Okay, so here we go with this next lesson, which is really an extension of the last lesson that we did, 7-2, okay? Raising a power to a power. You can use properties of exponents to simplify a power raised to a power like this. X to the fifth is the base, and you're raising that to the second power. You're essentially saying we're going to take this base, x to the fifth, multiply it together twice, okay? You can use repeated multiplication to simplify a power raised to a power. So you say, okay, and any base raised to the second power is that base times itself. So we've got x to the fifth times itself. And now instead of writing it like that, we've rewritten it in something that we did in last lesson, which is that we're just multiplying two powers with the same base, okay? So we've got a base of x here, and now the powers are 5 and 5. And remember, we add those together. So we say that's 5 plus 5 is the same as 5 times 2. And if you write it like that, you say, okay, that's 10. And that then becomes our rule. Notice that the exponent, when you're raising a power to a power, you multiply those two numbers. 5 times 2 is 10. Raising a power to the power is the same as raising the base to the product of the exponents, or the multiplication of them. Okay? That's different than repeated multiplication like this, same base, and you're just multiplying. When you're just multiplying, you add. It's kind of like a step down in the thing that you do, right? Like, adding is a simpler thing of multiplying. So when you're multiplying, these things become addition. When you're raising a power to a power, they become multiplication. Okay, so multiplication like this doesn't mean multiply them. Okay, raising to a power doesn't mean 5 to the second power, 25, right? You just multiply them, and in this case, when it's just multiplying, you add. Those are our rules. Okay. To raise a power to a power, this is the property down here. Multiply the exponents. A to the m as a base, multiply together n times, or a to the m raised to the n. You get the two exponents multiplied, a to the m n multiplied together. We're not going to use the base of 0, and we're always talking about having rational numbers for our exponents. Okay. Here's an example. 5 to the fourth raised to the second. Okay, we multiply the exponents together. 4 times 2 is 8, 5 to the 8th. Keep the exact same base. You're not also raising this. We're not getting 25 to the 8th. The base stays the same. Okay. Right here, a to the 3/2 raised to the third. Remember, we're going to multiply them together, so we're going to do 3/2 times 3. And that becomes 9/2, because you can imagine that as 3 over 1. And then 3 times 3 on the top, 2 times 1 on the bottom. Okay. M cubed raised to the fifth power, or m cubed times m cubed times m cubed times m cubed times m cubed. We'd have 3 times 5, or 15 m's multiplied together at the end of that. And finally, we can take this base of x to the 1/2 and raise it to the 3/5. We're now multiplying the exponents together, because it's raising a power to another power. And when we multiply these together, 1/2 times 3/5, 1 times 3 is 3, 2 times 5 is 10, and we get x to the 3/10. That's the gist of it. Let's see some example problems. All right, problem number 1 is asking for us to simplify a power raised to a power. What is the simplified form of n to the 4th raised to the 7th? Okay, and what does that equal? First thing I'm going to say is, should we be adding these numbers together or multiplying them together? Should you add or multiply the exponents to simplify the expression? You will multiply the exponents when we're raising a power to a power, and we are. We're raising n to the 4th to the 7th power. Since that's power to a power, we are going to multiply. Okay? So there it says, n to the 4 times 7, multiply the exponents when raising a power to a power. And when we simplify that, we get n to the 28th power. That is the answer to A. What is B asking? What is the simplified form of x to the 2/3 raised to the 1/2 power? So the base is x to the 2/3, and we're raising that to the 1/3 power. Essentially what we're doing is we're rooting it. We're saying what times itself equals x to the 2/3. And fun fact, you might notice that x to the 1/3 times x to the 1/3, when we multiply them together, we add the bases, or add the exponents, and those exponents would add to 2/3. So we can have a good guess that it's going to be that, right? What number times itself equals x to the 2/3? Well, this, right? Because that's what it says when you do it to the 1/2 power, is root it. What times itself equals this. So that equals that. But just let's check out when they show us what that looks like. What you do here is, following the rule, you say x to the 2/3 to the 1/2 means you are raising a power to a power, and you multiply, and you get really x to the 2/3 times 1/2 in the exponent part. Okay? And as you can see then, when you multiply this together, you get 2/6. 2 times 1 is 2, 3 times 2 is 6. And this simplifies to 1/3, and that makes sense because you can see that the 2 cancels out top and bottom. And as I said then, okay, we have as an answer x to the 1/3 right there. And just checking that up here, this is what they were saying up here. What number multiplied by itself will give you this? Because this is saying take the root of it, or find the number that when multiplied by itself gives you this. Okay? And that is our answer. If we took that answer and we multiplied by itself, we would have to add these two exponents together, and we would get x to the 2/3, what we had originally started with as our base. Okay? Here's your got it problem. It's really several problems because they're hopefully straightforward. What is the simplified form of each expression for a through d? And then in E, it asks, is a to the m raised to the n equal to a to the n raised to the m? Is that true for all values of m and n? And let's try that. Write your answers down or come up with your answers for each one of these, and pause the video, do it, and then come unpause the video and we'll check your answers. So pause it right now. Okay, so let's do these one at a time. P to the 5th raised to the 4th, we're going to multiply the exponents. 5 times 4 is 20. We get p to the 20th power. Okay. B, p to the 4th raised to the 5th power, we're going to multiply them. 4 times 5 is 20. We get p to the 20. And you might see how this relates to question E, but we'll keep going and we'll solve all of these and then we can re-examine that. C, p to the 1/2 raised to the 1/4, we're going to multiply those. So we get p to the, what is 1/2 times 1/4? We can do it just down here and erase it. 1/2 times 1/4, 1 times 1 on the top, 2 times 4 on the bottom, or 1/2 of 1/4, 1/8, p to the 1/8. Okay, and finally we've got p to the 1/4 raised to the 1/2. So we have for D, p, what is 1/4 times 1/2? We just did that. It is 1/8. So then what the question becomes down here is it true that if you had a to the m raised to the n, would that equal a to the n raised to the m? And basically, A and B go together to show that, and C and D go together. If you change the order of these, because of the commutative property of multiplication, you can change their order, and you will still get the same number 20, right? So p to the 5th raised to the 4th is the same as p to the 4th raised to the 5th, just like this says. Can you essentially switch the position of that base's exponent with the exponent it's being raised to? Same thing here. We switched 1/2 and 1/4, and we got the same solution. So yes, it is true for all integers m and n. You could swap those exponents and you would get the same answer. Okay, simplifying an expression with powers. What is the simplified form of this? Y to the 3rd times y to the 5/2 raised to the -2. And man, yikes, where do we start? Well, what is the first step in simplifying the expression? If you're following order of operations, by order of operations, you do powers. You simplify powers before you do multiplication. We're multiplying between these two numbers, but this one is being raised to a power, so we need to deal with that first. Gotcha? Okay, so you multiply the exponents when raising a power to a power. This is raising a power to another power, so we have to multiply them. So what we're going to get, y to the third stays what it is here, but this y to the 5/2 raised to the -2 means that you're going to multiply 5/2 times -2. Okay, and when you do that, you still get this y to the third. That doesn't change yet because we have to multiply after sorting this out. And when we sort this out, 5/2 times -2 is -10/2. Okay, obviously we can simplify that. We'll see that in the next step. So it says you add exponents when multiplying powers. So now they've simplified this right here, -10/2 to -5. That's the same thing, right? And since we have y to the third times y to the -5, they both have the same base of y, so we're going to add the exponents together. We're going to add the 3 and this -5. 3 plus -5. Okay, and what do we get when we do that? We get -2. 3 plus -5 is -2. So y to the -2nd power. Since it says simplifying, you've been seeing in the book that what it's asking you to do when it says simplify in this form is to actually get rid of the negative exponent by jumping it over the fraction bar. Okay, so write the expression using only positive exponents, and that then becomes, instead of y to the -2, it's y to the second, changing its sign by jumping it over the fraction bar into the bottom. And since there's nothing left on top, it's a 1. 1 over y to the second. Hopefully you know this by now. Now, what's the got it problem? Okay, you're going to simplify each of these expressions. And I'm telling you to pause the video now and write your answers down, solve this best you can, and make an honest effort to do this. And then come back and compare your answers with what the actual answers are that I'm going to write. Pause now. Okay, so what is the simplified form of these? What we need to do, as they said, is we need to identify what's being raised to a power, and we need to simplify that. This x to the 6th is being raised to the -4 power. So we need to keep this x squared in the front what it is, because we're eventually going to multiply, but not until we sort this part out. And since it's power raised to another power, we multiply them. 6 times -4 is -24. So we got x to the 2nd times x to the -24. And now we have two values being multiplied together, x squared times x to the -24. They have the same base, so we can add their exponents together. And when we add their exponents together, we get x to the -22. And of course, simplifying it fully means turning it into having a positive exponent. So this negative exponent means we got to jump it down to the bottom of the fraction bar. We have a 1 on top, and we used up that negative in order to jump the bar. So it's now a positive x to the 22nd on the bottom, and that's the answer to that one. Okay, let's keep going. For b, we also have these being multiplied together, w to the -2nd power, and this w to the 5/3 raised to the 3rd power. So we're going to deal with that first. I'm going to first keep w to the -2nd power, what it is, and here we're going to do w and 5/3 times 3. I can write it up here as a small little exponent to the 5/3 times 3, and that's, or same as 3 over 1. And as you can see, that 3 top and bottom will cancel out, giving you 5 over 1, or just to the 5th power. So then we get w to the -2 times w to the 5th. And when we're multiplying two things together, these are being multiplied, we will add their exponents. What's -2 plus 5? It is 3. So we get w to the 3rd power. And that's a positive exponent. We'll keep it like that. Okay, let's keep going. We've got two parts to this. This first part, s to the -5, is being raised to a power of -1/2. We have to deal with that first. So we'll keep this s to the 3/2 the same for a moment. And we'll write this first one, s to the, and we need to multiply these values. What is negative 5 times negative 1/2? Negative times negative is positive, and 5 times 1/2 is 5/2. So we get then s to the positive 5/2 times s to the 3/2, which is what it already was. Now we can get to this part where we multiply them, and since these powers are getting multiplied together, we can add their exponents. So then we get s to the 5/2 plus 3/2 is 8/2. And of course, 8/2 can be simplified. 8 divided by 2 is 4, so s to the 4th power. That's how you do it. Okay, so we're going to have a new property here. It says you can use repeated multiplication to simplify an expression like 4m to the 1/2 raised to the 3rd. And notice that we actually have this coefficient here on m to the 1/2, that 4, trapped in with parentheses. That means that this power of 3 is acting on all of that, and that's what's the difference here. And let's see how that plays out. Okay. Remember, if you raise something to the 3rd power, it means you multiply it together by itself 3 times. So we can take this and write it like this. And now, as you can see, we have this 4 getting multiplied together 3 times, just like this m to the 1/2 is going to get multiplied together 3 times. Okay? We reorder them. The commutative property says that we can rewrite their order to put all of the coefficients together and then put all of the powers with the same base together. And then when we do it, we say, okay, that writing that with exponents, we say that's 4 multiplied together 3 times, or 4 to the 3rd. And remember, when you're multiplying powers with the same base, you can add their exponents. 1/2 plus 1/2 plus 1/2 is 3/2. So m to the 3/2. We can simplify this part. 4 times 4 is 16, times 4 is 64. And so we got 64m to the 3/2. That's the answer to that. Okay? And it says, notice that 4m to the 1/2 all raised to the 3rd power is the same as distributing that exponent of power of 3 to each piece of it, to the coefficient and to any variable with its exponent. So the 3 goes on to here as a 4 to the 3rd power, and the 3 goes on here, m to the 1/2 to the 3rd power, or m to the 3/2 power. Okay, and this example illustrates another property of exponents, which is when you raise a product to a power, you raise each factor, each thing that's in there. In this case, there was the 4 and there was the m to the 1/2. You raise each factor to that power and multiply. So if you have things like this being multiplied together, just like you have the 4 being multiplied with the m to the 1/2, you put that exponent on each one. So ab as a base raised to the n is the same as a to the n times b to the n. Okay, we're not using bases of 0, and we're talking about when we have rational numbers for our exponent, either a whole number or an integer, positive or negative number, or a fraction. Okay, so here's some examples. What do? They say, okay, if you raise this base of 3x to the 4th power, you're raising 3 to the 4th power and that x to the 4th power as well. And this simplifies to 81. Same thing here. If we're going to raise 4b, the whole base, to the 3/2 power, then that 3/2 goes on the 4, and that 3/2 goes on the b. Now let's just quickly examine this part of it, 4 to the 3/2 power. You should remember that 4 to the 3/2 power is, what we can do is we can do the denominator first, okay, and then raise the answer to the numerator. And what is 4 to the 1/2 power, or the square root of 4? What number times itself equals 4? That's 2. So we have a base of 2, and we still have to raise it to this 3rd power here. And what do we get there? We get 8. And that's why they have 8 right here. Okay? Let's do a couple practice problems with this. Okay, this is great because we're kind of actually starting to hint at a little bit of geometry, which is going to be your next course. Which expression represents the area of the square? Remember, area is, for any rectangle, is base times height. But since it's a square, the base and the height are exactly the same. So we're essentially saying that side length times itself, or that side length squared. Okay? So what does that look like? Well, they're giving us multiple choice. What could it be? Okay? And of course, I've been saying this to you all, the best thing that you can do instead of sorting through the multiple choice answers is just try and answer it on your own without looking at your choices, and then see if your choice is there. Okay? So let's see what they do. They say, what we're really doing is we're taking that side length times itself, because we always do that times that for rectangles, and since it's a square, it's the same twice. So we multiply it by itself or raise it to the second power. Okay, when we do that, remember we got to distribute that to the second power to each piece, to the 5 and to the x cubed. Okay, so that's what they do here. 5 to the second and x cubed to the second, raise each factor to the second power. And of course, we can multiply, we have to deal with the powers, the exponents first, right, in order of operations. So we say, let's do that here, x cubed to the second power, power of a power, we multiply x to the 6th. Okay, you could also have done this in the same step since it's also raising to a power, but they do it separately. Simplify, 5 squared is 25, so 25x to the 6th power. Okay. How do you find the area of a square? The area of a square with side length s is s squared. As I said, you multiply the side length times itself. Okay, square the side length of the square to find the area. So that's what we did. We squared this. Okay. And looking for that answer now that we did it, that right there, 25x to the 6th, that's choice D. So your answer is D. Your answer is not this, it's D, because if you're multiplying, doing a multiple choice question, they're asking A, B, C, or D. Okay, got it? Let's check this out. You're going to pause this video now and try these problems and unpause it to check your answers. Pause your video now. Okay, so what do we need to do? We need to give that exponent to each piece of that. So I'm going to rewrite it as 7 to the 3rd times n to the 9th raised to the 3rd. I can do better on that 9. Okay. 7 cubed is 7 times 7 is 49. 49 times 7 is 343. So 343. And remember, when you raise power to a power, you multiply the exponent. So 9 times 3, and we get 27. So m to the 27th power. Okay, doing the same thing for b. We say 2 to the negative 4. Each part of it gets that exponent. And sorry, my pen is going a little funny here. And then the z gets the negative 4 as well. Now we need to simplify this, okay? If they both have negative exponents, so you could have guessed they're both going to jump to the bottom. And another way of thinking about that I'll show you in a second. So 2 to the negative 4 is the same as 2 to the 4th on the bottom, 1 over 2 to the 4th. Like that. Oops. And times z to the negative 4 is the same as 1 over z to the 4th. So if we simplify this 2 to the 4th here, we'd get 1 over 16 times 1 over z to the 4th, or 1 over 16z to the 4th. Okay? And another way you can do it, I'm going to do it over here in red, would be to say, I'm going to take this 2z to the negative 4th, which is what they gave us, and I could give each piece the negative 4. I could also say, I'm going to apply that negative to this base and move it to the bottom, and then we have 1 over 2z, still in parentheses, all raised to the 4th power. And then you could distribute that 4 to each part and say that's the same as 1 over 2 to the 4th z to the 4th. And of course, 2 to the 4th equals 16. So it's on the bottom, you get 16 z to the 4th, just like we did here. So we get that for both of those. Okay. And finally, we distribute this -2 to each part. So we get 3 to the -2 times g to the 4th raised to the -2. Okay. So we could move that to the bottom, 1 over 9, because the negative puts it on the bottom, and 3 squared is 9, times, and we'd have that negative putting this whole thing on the bottom, and we raise g to the 4th to the 2nd power. G to the 4th raised to the 2nd power is g to the 8th. And multiplying them together, we get 1 over 9 g to the 8th. Okay, let's see if we can put this all together for this last most complex problem. Here's what it looks like. What's the simplified form of this expression? Okay, remember what we need to do. We say if we have anything that's raised to a power, we need to do that first. We need to deal with this separately and raise that to the 10th power. We need to deal with this separately and raise that to the 3rd power. Then we can multiply together what we have there. So you can see that they're saying, okay, right here, the first step that they're doing, they're keeping this the same, but they're saying let's distribute this power to a power. Just distribute it through to each part. It goes to the 4, it goes to the m, and it goes to the n term as well, and to the -2/3. Okay, that's a little sloppy. Sorry about that. The way that they write that, sometimes the book gets their things jumbled, but that says 4m n to the -2/3. Okay. So what do we got next? Oh, and by the way, what is the exponent of m? Remember, it has an implied exponent of 1. So 1 times 3 is 3. Okay, similar to coefficients, exponents of 1 don't need to be written. You already knew that. So what do we get now? Well, what do they do here? Let's see. They'll tell us they multiply the exponents of a power raised to a power. So they say, let's multiply this is being raised to the 10th power. What's 1/2 times 10? It's 10/2 or 5. So that simplifies down to 5. Here, 4 to the 3rd power, they're going to keep it as what it is for now. M to the 3rd power, we're going to keep it what it is for now. And this one now we have to multiply. What do you get when you do -2/3 times 3? Well, if we write it on the bottom real quick, -2/3 times 3, or 3 over 1, you can see they cancel out. So -2/3 times 3 is -2. Oops, let me get this out of there. Okay, so that's where we get this -2 here. Oops. Okay, now what do we need to do? Well, there's a couple of things that we need to do here. We need to resolve this 4 to the 3rd power, and we need to put these n terms together because there's 2 of them, and we have to now then add their exponents. Okay. Commutative property, they're just reordering them first to put these next to each other, and then they're saying, okay, they have the same base. Multiplying with the same base, we add those exponents together. And of course then 4 to the 3rd power, 4 times 4 times 4 is 64. M to the 3rd, there's nothing to combine it with, so it stays. And n to the, what's 5 plus -2? It's 3, so n to the 3rd power. Try yours now. Here is your got it problems. And this will be the end of this lesson once you try this. But because this is the most complex part, you really want to see, did I put all this together? So pause the video now and try these problems, write them down, compare them to the answers that I'm going to give you when you unpause the video. So stop it now. Okay, let's do it. X to the -2 raised to the 2nd, that is power of a power, so we multiply them together and we get x to the negative 4 times, this part we need to distribute through that to the 4th power here. That's going with all of these terms. We need to give it to each one. So we say 3 to the 4th times x to the 1st, really, to the 4th. So, and y to the 5th to the 4th. Okay? And as you can see, then we need to resolve this part first. So we're going to keep this just for a second. X to the negative 4 times 3 to the 4th times x to the 4th times y to the power raised to a power means we multiply them to the 20th. Okay? And now if we wanted to, we could reorder this and put the 3 to the 4th first. And we could say this x to the negative 4th then goes right next to this x to the positive 4th and times y to the 20th. And of course, what has the same base here are the x terms. And we then add the exponents together. And what is negative 4 plus 4? It's 0. And what is anything to the 0 power? 1. So this just becomes a 1. Those cancel each other out, x to the negative 4th and x to the 4th. As you can see here, if I did this, I'm going to write the x to the 4th like this. And x to the negative 4th means x to the 4th on the bottom. And there's exactly the right amount to cancel from each one. Cancel there and there, cancel there and there, cancel there and there, cancel there and there. And they all cancel out to be 1. Okay? So that should fit with everything that you already understand. Now, this becomes 1. This 3 to the 4th power becomes 81. And then y to the 20th. That becomes our answer. Okay? Let's keep going. We're taking this, raising it to the 4th power. We're taking this base and raising it to the 3rd power. So we give the exponent to each part. So 3 to the 4th times c to the 5/2, all raised to the 4th, okay, times c to the 2nd raised to the 6th. Okay, now 3 to the 4th times, we need to multiply these exponents together, power over power, we multiply it, and you can see how this 4 and this 2 cancel out. The 2 becomes a 1, the 4 becomes a 2, and we then get 5 times 2 or 10, so we get c to the 10th when we multiply that exponents there. And here we've got times c to the, oh, and you know what? I hope you caught that mistake. I wrote a 6 there, and I should not have. Wow. Thank you for the catching that. That should have still been a 3, and if that confused you, my apologies. Okay, I do make mistakes. So c to the 2nd raised to the 3rd power is c to the 6th. Okay, and now we can say, okay, let's multiply these two together. C to the 10th times c to the 6th is c to the 16th. And this 3 to the 4th power, you'll come to learn that because you're seeing it all the time in a bunch of different problems. 3 to the 4th power is 81. And you can imagine that as 3 to the 4th power is just by grouping them together like this. You really get 9 times 9, which is of course the 81 that you're looking for. Okay? So that becomes our answer for that one. And finally, let's do this last one and we're done. We've got to distribute this power of 3 to each one of these 3 factors, to the 6, to the a, and to the b. And we need to distribute this second power exponent to the 5 and to the a to the negative 3. So let's write it down. 6 to the 3rd times a to the 3rd times b to the 3rd times 5 is got an exponent of 2, so 5 to the 2nd. A to the negative 3 raised to the 2nd as well. Okay, and if we reordered these, which we could at this point, let's first deal with this right here. Okay, we've got 6 to the third times a to the third times b to the third, I'm just copying everything down, times 5 to the third times, times 5 to the second, because that one was only raised to the second power. And here we need to multiply these exponents together, so we get a to the negative 6. Okay, now's a good time to reorder them. We're going to put this 6 cubed at the front times this 5 to the second times, let's group the a's, times a to the third times a to the negative 6 times that b to the third. And what do we have like bases on? We have like bases on this a here, okay? So we can add those exponents together. What's 3 plus negative 6? It's negative 3. So we got 6 to the third, which, by the way, 6 to the third power is 216. And 5 to the second power is 25, times, we're going to combine these two, 3 plus negative 6 is a to the negative 3, and b to the third. Now, if we multiply 216 times 25, which is a legit thing to do at this point, we get, and you write it out longhand, but it's 5,400. Okay, this a to the negative 3 right here, since it's got a negative exponent, it's going to go on the bottom of this fraction as the positive exponent now, because we used up the negative to put it in the bottom. A to the third, and the b to the third doesn't move to the bottom, so that stays there, and we get as a final answer 5,400 b cubed over a cubed. There we go. That's the stuff. Hopefully that all made sense. Good luck. I know this is a long lesson and it's complicated, so you maybe want to watch some of the explanations twice. After this video, do the IXLs. It's really going to give you practice. Then try the homework problems, check your answers against the lesson page, and watch videos that you need to. And finally, then do the homework online for this particular lesson. Good luck.